Hi, this is Edward Lee, and I want to talk a little bit about language scaffolding as supports for ELL students learning mathematics. Mathematics turns out to be a very language intensive subject with heavy use of content specific academic vocabulary that is difficult to pick up in ordinary speech. Furthermore, Common Core standards are putting an increased emphasis on language to express mathematical ideas with others, putting ELL students at a disadvantage as they try to learn English and mathematic ideas at the same time. For example, you might hear in a math class, how do you solve for x? And a 3 plus 2x equals 9. How do you solve that equation? One strategy might be to identify the variables and the order of operations that manipulate the variable. And a strategy that could be used to solve that would be to apply the inverse operation to each of the original operations in reverse order to solve the equation. Now that's quite a mouthful. That's quite a mouthful for a normal student to learn, to understand, let alone an ELL student. And this is where language supports such as graphical organizers can help. Here's a graphical organizer that's created as a flowchart. It's something that I devised this morning. You might start out with a front-loading vocabulary. Students might know that they're going to have to solve for an equation. They might understand order of operations. You might bridge it to a prior lesson, such as PEMDAS. In a previous unit, we talked about order of operations as an example. That might be an introduction. Students also could leverage modeling, where a teacher goes off and goes through using one of these supports so that they understand what the flow is and how these ideas relate together. So let's just do this really quickly together. So if I were to solve this equation, 3 plus 2x equals 9, what is the variable? I say x is the variable. What is the first thing that I'm doing to x? I'm multiplying by 2. Then I'm add 3 to get to 9. Even though it says 3 plus 2x, we know from PEMDAS that multiplication goes before addition or subtraction. Then we would just follow the flow chart to reverse these things. So the inverse of add 3 is subtract 3. And the inverse of multiply by 2 is divide. Then I would expect the students to go to the second part of a graphical organizer and list the more traditional algebraic steps, step by step, in the order that they're presented in the original graphical organizer. In the second part of my graphical organizer, I've combined this into not only a column where we do the algebraic steps, which I have shown here, already outlined, but with a place to write out English equivalents. And I think the English equivalence is very important to help students really learn mathematics. Subtract 3 is the inverse of add 3. Therefore, we subtract 3 from both sides of the equation to preserve equality. That is an example of how a graphical organizer can be used.